Things fall.
One.
Where why?
Good drop.
It's something we learn from a young age. Though we didn't really have an idea of why until a nice summer day in 1666 when Isaac Newton watched an apple fall from a tree. In the year 1666, he retired again from Cambridge to his mother in Lincolnshire, and while he was musing in a garden, it came into his thought that the power of gravity was not limited to a certain distance from Earth, but that this power must extend much further than was usually thought. Why not as high as the moon? Gravity, or more broadly gravitation, is the force manifested by acceleration between two objects, the force that attracts all objects together. Things fall because they're attracted to the Earth. In most high school physics, or just science classes, you learn that the acceleration on the Earth's surface due to gravity is 9.8 meters per second squared. Newton's law of gravitation tells us that every particle of matter attracts every other particle with a force that is directly proportional to the product of their masses and inversely proportional to the square distance between them. In other words, the force of gravity is equal to the gravitational constant times the masses of two objects divided by the distance between them squared. This is how you can also find the acceleration due to gravity, by taking the gravitational constant times the mass of the Earth and divided by its radius squared. So, that's it. That's all you need to know for a low-level physics class about gravity. Stuff is attracted to each other, and that means they exert forces on each other. But why? Why is everything in the universe attracted to each other? Is it as simple as the thought of everything having a magnetic-like pull that makes these attractions and forces happen? Well, no. Not really. Einstein's theory of gravity basically rejects the whole idea that everything is attracted to each other. Einstein's theory of gravity is geometric, and not based on the idea of a force. It's just a distortion in space-time, and things fall towards each other in these distortions. He basically claimed that gravity isn't even a force back in 1915. According to the theory of relativity, gravity is the result of distortions in space-time created by mass and energy. The principle of equivalence states that both mass and acceleration distort space-time and are indistinguishable in comparable circumstances. But how does this work? If you imagine space-time as a piece of paper or a sheet, and let's say the Earth or the Sun to be a ball, and you place them on the sheet will be distorted where the ball is and sort of fall in. If you put smaller balls on the sheet, anything that's close enough will fall in towards the bigger ones. So, why are we taught that gravity is a force, and all things are attracted to each other, if it's been proven time and time again that Einstein's theory is practically true? Because it's simple, and the equations still work. Even though gravity might not be a force, it still behaves force-like. Just looking at it all purely mathematically, there's nothing fundamentally wrong with Newton's version of gravity. So we keep learning and teaching it to lower-level physics students because it still just works. Though, Newton himself lamented that his law of gravity was merely a description of gravity that did not explain what gravity is and why it occurs. Newton's theory faced lingering paradoxes and observations that weren't perfectly in line with the theory's predictions. The theory or idea of gravity is even still being played with. In the quantum theory of gravity, the gravitational force would be carried by a particle called a graviton, but we have never experimentally detected such a particle, nor do we have a working quantum theory about gravity. Gravity might not be what you thought, but it still practically works the same. Here are my works cited with the information, images, and such that I gathered to make this video. Everything has a number or letter corresponding that should have popped up on the screen at the time of it being used.